Also with an emergent need for smart innovations in learning in healthcare. About the today's workshop, today artificial intelligence and machine learning applications has become part of our modern society. Their application ranges from e-commerce to healthcare, resource management, cybersecurity, logistics, supply chain, and many more. Intelligent machines are influencing nearly every facet of our lives to help improve efficiencies and augment. AI is so intertwined in all that we do. This workshop paves a path to understand AI and ML and apply the principles of both in a real-time scenario. With this, I would like to invite the convener of today's conference, Dr. Sharvari Tamane, to say a few words about the international conference. Over to him, ma'am.
Thank you, Madhuri. Warm welcome and good morning to all respected dignitaries of MGM University, Aurangabad, Vice Chancellor, Honorable Dr. Vilas Sarkar sir, keynote speaker, Dr. Krishnan Umachandran, my colleagues, and all participants. On behalf of UDICT MGM University, Aurangabad, I welcome you all for the inaugural function of the international workshop on AI, ML, and DL. The main goal of this workshop is to provide opportunities for the researchers, academicians, industry persons, and students to interact and exchange ideas by providing unrestricted access of collected corpora towards research and development, as well as performance assessment opportunities at national and international level. The response for this workshop was very good. I'm fortunate to be associated with this workshop in the capacity of convener, and I'm happy to share that we have received 168 entries for this workshop across the country, and I'm sure that each one of us is going to interact and enjoy ourselves during the scientific sessions today. We have invited renowned personalities in the field to share their expertise and experiences with all of us in keynote, as Madhuri has already mentioned. So I appeal to everybody to interact with the speakers to make all the sessions lively and interactive. Thank you. Over to you, Madhuri. Okay, I think Madhuri is not audible. Yeah. Please go ahead.
It's now my privilege and my pleasure to introduce Honorable Dr. Vilas Sarkar sir, Vice Chancellor, MGM University, Aurangabad. Shortly, I will going to introduce to the sir. Sir had completed his PhD from IIT Bombay. He has 35 years of experience in industry, teaching, research, and administration. He has been served as Vice Chancellor of Rashtrasant Tukadoji Maharaj, Nagpur University, Nagpur. He also served as acting Vice Chancellor of Kavi Kulguru Kalidas Sanskrit Vidyapit, Ramtek, Nagpur, and Sant Gadge Baba Amravati University. He had been nominated as an expert by the President of India for selection of professor in chemical engineering at IIT Bombay. He has also been nominated as a member by Chancellor of the Universities on Maharashtra State Council for Higher Education. Sir has worked as an expert for establishment of Indian Institute of Information Technology and private university by Department of Higher and Technical Education of Maharashtra government. Sir has worked as chairman of the committee to survey for the starting courses related to cyber law by the Maharashtra government and handle responsibility as a member of committee by Maharashtra government to formulate policy for award of ideal teacher in the state. He has been appointed as a chairman of the committee by the state government to standardize academic programs, examination pattern, and evaluation method in all the universities in the state. He worked as an expert for selection of finance and account officers, controllers of examination in other universities. He has been appointed as visitors nominee for selection of registrar at Central University. He has been nominated as chairman All India Board for PG Education and Research of AICTE and also appointed as chairman Standing Appellate Committee of AICTE. Dr. Vilas Sabkar sir has also worked as member of search committee for selection of vice chancellor for Rajiv Gandhi Technology University, Bhopal. Sir has received the Distinguished Service Award from Sant Gadge Baba Amravati University, ChemCon Distinguished Speaker Award by the Indian Institute of Chemical Engineers, Leadership Award by Lokmat, and Convention Speaker Award by ISTE. Till date, Sir guided 20 research scholars and 2 scholars are pursuing doctorate under his guidance. Total 45 students pursued MTech degree under his guidance. Sir has published 130 papers in national and international conference. So without further delay, I request Dr. Vilas Sabkar sir to address the audience with his valuable inputs. Over to you, sir.
Thank you for your kind words. It should have been for the short, actually, not so long, but nevertheless, I extend very warm welcome to all the our invited speakers, experts, delegates, as well as participants for this one-day international workshop on artificial intelligence, machine learning, deep learning in industry and healthcare, organized by convener Dr. Sharvari Tamane, Professor and Head of University Department of Information and Communication Technology. MGM University team consisting of Registrar Dr. Ashish Gadekar and Dr. Shinde, Dean of Engineering and Technology, are always focus on creating the platform to bring together experts from industry, research organization, and academia to share the ideas related to recent trends and developments and giving the best opportunity to the researcher as well as students to know the requirement, the gap in industry and academics, as well as explore the new areas of application. As you know that still the whole world is facing health issues related to pandemic and the new complications are arising every day. But nevertheless, artificial intelligence and as you know that the smart medical treatment or approach will definitely overcome this pandemic situation and will offer the very healthy and sustainable solution to our healthcare industry. As you know that university plays very important role in not only creating the knowledge through research, but also explore the innovative ideas so that our students can not only get the clarity of concept, that is proof of concept, but application of concept, and then can convert it into incubated ideas so that finally they can start their the new business. I'm sure that these new areas are making possible to bring together the different disciplines and truly making the holistic development of learner. As you understand that this platform is offering the experts not only to share their expertise but also link with the new talent and the new brain that will really come forward for new application. I'm sure that this workshop is at the end can come out with a very good suggestion and which can be documented and also can be guideline to the to our master level students or research scholar also. As you know that university, though it has started uh, different programs in different disciplines, including engineering and technology, biotechnology, as well as design and the School of Engineering and Technology. The university is creating the interdisciplinary platform for advanced research, which will be taken up by the industry. When we talk about multidisciplinary research, it ensures the level of confidence of the outcome of the research, and then it becomes very easy for commercialization of the technology development. I'm sure that these new rising areas will definitely find out new applications, and what is the focus area is utilize the resources optimally, smartly, so that the frugal engineering, that is minimum inputs and maximum outputs, can be achieved. So I wish all the best for this workshop, and thank the organizer for giving me this opportunity to interact with our experts nationally and internationally. And I wish all the best for the success of this workshop. Thank you so much.
Thank you, sir. We are grateful for the time and the effort you took to share your thoughts and experiences with the audience. Your comments were very timely. I believe we can benefit a great deal from your ideas suggested. Thank you again for your advice. We are sure that principals and participants will apply principles of AI/ML in real-time scenario. With this, we have concluded our inaugural session. I thank once again to all the honorary chairs and esteemed guests. Now we will be starting with our keynote addresses.
Thank you.
Thank you, sir.
Thank you. I like to listen,
Shall
but
we start?
since I have some more appointments, so I will leave now. But I would like to get the report at the end of the day so that we can take it further.
Yes, sir, definitely.
Thank you. Thank you. Krishnan sir, I will
Thank you, sir. Thank you, sir.
look forward to meet you. Okay.
Sure, sir. Sure, sir. I'll come.
So all the expert, Dr. From Bangalore, Dr. Varela Lakshmi, and Varela Lakshmi.
Thank you, sir.
Yes. Naples. Thank you, sir.
Now, I would like to introduce our first keynote speaker, Dr. Sharvari Tandeman. She is the professor and head of Department of Information Technology in Jawaharlal Nehru Engineering College and head of University Department of Information and Communication Technology at MGM University, Aurangabad. Ma'am completed her BE in CSE from Dr. Bamu, post-graduation in Computer Science and Engineering from the University of Mumbai, and PhD in CSE from Dr. Bamu. She has 25 years of teaching experience in Jawaharlal Nehru Engineering College, Aurangabad. She has published 3 patents and 2 copyrights in the Indian Patent Advanced Search System, Government of India. Her areas of expertise are cloud computing, security, big data, network, fuzzy logic, and many more. She edited 3 books and is the author of 10 chapters published by IGI Global USA and Springer. She published more than 70 research papers in international conferences and journals. She has been awarded Best HOD of the Year at the CSI Tech Next India Awards to the Academia. She had been invited as a panel at national and international conferences like Mauritius and many more. For international conferences, he has invited as a speaker for Women in Data Science Conference, Pune, and the event What Makes a Data Scientist, organized by Stanley College of Engineering and Technology for Women at Hyderabad. She has also invited to many institutes to deliver keynote and expert talks on various research areas. She has also worked as program chair for IEEE and CSI sponsored international conferences held at JNC MGM University, Aurangabad. 3 research scholars have been awarded PhD CSc degree under her guidance, and currently she is guiding 8 research scholars from Dr. Babasaheb Ambedkar Marathwada University and MGM University, Aurangabad. I request Dr. Sharvari Tamane Madam to deliver a session on Introduction to Machine Learning. Over to you, ma'am.
Thank you, Madhuri. I'm not going to take much time. I'll be speaking only for 15 minutes, and then we'll be having two more keynote speakers for half an hour. So is my screen visible?
Yes, ma'am. Yes.
Yeah. So my topic is machine learning, supervised and unsupervised learning. So respected dignitaries and all participants. So these are the table of contents of my presentation. So as all of you know that the machine learning has the ability to learn if it can improve its performance by gaining more data. And that is true because nowadays we are surrounded by humans who can learn everything from their experiences with their learning capability. And we have computers or machines which work on our instructions. But can a machine also learn from experiences or past data like a human does? So here comes the role of the machine learning. So it is said that it is a subset of artificial intelligence that is mainly concerned with the development of algorithms which allow a computer to learn from the data and past experiences on their own. And therefore, the definition as the machine has the ability to learn if it can improve its performance by gaining more data. So it enables a machine to automatically learn from data, improve performance from experiences, and predict things without being explicitly programmed. So with the help of sample historical data, which is known as training data, machine learning algorithms build a mathematical model that helps in making predictions or decisions without being explicitly programmed. A machine learning system learns from historical data, builds the prediction models, and whenever it receives new data, it predicts the output for it as shown in the diagram. So the accuracy of the predicted output depends upon the amount of data, as the huge amount of data helps to build a better model which predicts the output more accurately. So suppose we have a complex problem where we need to perform some predictions. So instead of writing a code for it, we just need to feed the data to generic algorithms, and with the help of these algorithms, machine builds the logic as per the data and predict the output. So there are different features of the machine learning. Machine learning uses data to detect various patterns in a given data set. It can learn from past data and improve automatically. It is a data-driven technology even. The need of machine learning is now increasing day by day. The reason behind the need of machine learning is that it is capable of doing tasks that are too complex for a person to implement directly. As humans, we have some limitations as we cannot access the huge amount of data manually. So for this, we need some computer systems. We can train learning algorithms by providing them with a huge amount of data and letting them explore the data, construct the models, and predict the required output automatically. The performance of the machine learning algorithm depends upon the amount of data, and it can be determined by the cost function. So with the help of machine learning, we can save both time and money. So nowadays, machine learning has got a great advancements in its research, and it is present everywhere around us, such as self-driving cars, Amazon Alexa, cardboards, recommender system, and many more. It includes supervised, unsupervised, and reinforcement learning with clustering, classification, decision tree, and SVM algorithms. Modern machine learning models can be used for making various predictions, including weather prediction, disease prediction, stock market analysis, etc. So there are different machine learning approaches. Like traditionally, it is divided into three broad categories: supervised learning, unsupervised learning, and reinforcement learning. In supervised learning, the computer is presented with example inputs and their desired outputs given by a teacher, and the goal is to learn a general rule that maps inputs to outputs. In unsupervised learning, no labels are given to the learning algorithms, leaving it on its own to find structure in its input. Unsupervised learning can be goal in itself, where it discovers the hidden patterns in the data or a means towards an end. And in reinforcement learning, a computer program interacts with a dynamic environment in which it must perform a certain goal, such as driving a vehicle or playing game against an opponent. As it navigates its problem space, the program is provided feedback that's analogous to rewards which it tries to maximize. But what is exactly the supervised learning? It is a prediction of labeled data, that is, the computer learns from past data where both independent and dependent data are present. It acts as a teacher to the machine. The variable which we predict is called as the dependent variable or the target variable, and the variables which we use for prediction are called predictors or independent variables. So on a very basic level, machine learning is not vastly different from the way humans learn. For instance, if you show a pair of shoes and a pair of socks to a child, the next time he can point out a pair of socks and identify them. So the higher the number of shoes and the socks he comes across, the better he is at identifying them. So something similar happens in machines. The data about shoes and socks that have been fed to the system is called the training data. There are many types in a way that machines can learn. That is, the supervised learning technically means the learning of a function that gives an output for a given input based on a set of defined input-output pairs. It does this with the help of labeled training data that consists of a set of training examples. And in our previous example, the picture of shoes and the name shoes are input and output respectively. So after learning from the hundreds or thousands of different shoe pictures and the name shoes, along with the same for the socks, when our system is given an input, it will give an output. That is in case of the previous example, we can give the input as a picture of shoe, and the output generated will be the name of shoe. So often the function y is equal to f of x is used to represent supervised machine learning, where x is the input data and y the output variable, and a function of x that is to be predicted. So in any training data, the example pair normally consists of an input data that is typically a vector and the desired output value, which we call supervisory signal, the meaning of which is easy to understand from the name. Supervised learning is classified into two different categories, like regression models and classification models. So it builds a relation between the dependent variable and independent variables. It is used for continuous data. For example, suppose we want to predict the cost of a house The cost of a house is dependent on the program parameters like number of bedrooms, bathrooms, and the area of the room. The cost of the house increases with increasing our requirements. And if the parameters we place it on x-axis and the cost of house on y-axis, the relation will be linear. And the regression predictive algorithm does not identify a category of the variable, but assigns a quantity or number to it based on the historical data. So it uses the relationship between an independent variable and a dependent variable from the historical relationship data and predicts a quantity. So common example of this is predicting temperature on a particular day or predicting commodity prices with respect to time. The data points in regression have continuous values. And if you're seeing the image, so it shows how a straight line is drawn through all data points in order to depict a linear relationship, which is called the linear regression. And if the system encounters a value of age, say 10, so for which we do not have any training data, the system can still predict a numerical continuous value in between some range, for example, 1.3 to 1.4 based on the historical relationship. There are different steps involved in supervised learning. First step is determine the type of training examples. For example, deciding on the type of shoes and socks images or cats and dogs examples to be fed for training. So we need to determine the training examples. Then second step is prepare or gather the training data. All the input and output values in labeled form have to be gathered. The set should be representative of the real world applications of the function. For example, if there are 30% of a particular breed of dog in the real world, the percentage in training data should not be 60%. Even for semi-supervised learning, although most part of the data is not labeled, it should still be relevant to real world conditions. Next step is determine relation between input feature and representing learned function. So the input features in practical cases will not be simple as shoes and socks, but complex with multiple features, thus used typically as vectors. So this means the accuracy of the function may vary and the number of features should be optimum for optimum accuracy. Next is select a learning algorithm. Selection of the correct algorithm matters in both supervised and unsupervised learning. A variety of algorithms are available for selection, and there is no single perfect one, but the one suitable to the problem's need should be selected. For example, the linear regression model can be selected when the relationship between variables is linear. And decision tree model can be selected where a decision on final value is to be made based on a set of sequential input variables. Next step is run the selected algorithms on training data. So running algorithm completes training and performance can be optimized by using cross validation using a validation set of variables. Next is evaluate the accuracy of the learned function using values from test set. So the function is ready to use, but after measuring the performance on a test set of variables, which is different from the training set. So these are the various steps which are involved in supervised learning. There are some common issues faced while using the supervised learning. There is a lot of computation time is required for training and also for classification, especially when big data is involved. Sometimes overfitting is also there. The model may learn the noise in the data to such an extent that instead of Considering it an inconsistency, it can be considered a concept for learning. And basic difference between supervised and unsupervised learning is, in case of an input which cannot belong to any class, instead of creating a new class, the model will include it in one of the existing ones. So these are some of the issues which we faced while using the supervised learning. There are different practical applications of supervised machine learning. For beginners, at least, probably knowing that what does supervised learning achieve becomes equally or more important than simply knowing what is supervised learning. So a very large number of practical applications of the method can be outlined here. And so following are some of the common examples we can say: detection of spam, then detection of fraudulent banking or other activities, medical diagnosis, image recognition, predictive maintenance. With increasing applications each day in all the fields, machine learning knowledge is an essential skill. Next is about unsupervised learning. I'm going too fast because of the time constraint. So please excuse me for that. Unsupervised learning is a class of machine learning techniques used to find patterns in data. The data given through unsupervised algorithms are not labeled, which means only the input variables are given with no corresponding output variables. In unsupervised learning, the algorithms are left to the users to discover interesting structures in the data. And as we know that there are different applications of the unsupervised machine learning, which includes clustering, anomaly detection, association mining, latent variable. Clustering allows you to automatically split the data set into groups according to similarity, where the cluster analysis overestimates the similarity between groups and doesn't treat data points as individuals. And for this reason, cluster analysis is a poor choice for applications like customer segmentation and targeting. In anomaly detection, it can automatically discover unusual data points in your data set, and this is useful in pinpointing fraudulent transactions, discovering faulty pieces of hardware, or identifying an outlier caused by a human error during the data entry. In association mining, it identifies set of items that frequently occur together in your data set, and retailers often use it for basket analysis because it allows analysts to discover goods often purchased at the same time and develop more effective marketing and merchandising strategies. And in case of latent variable, models are commonly used for data pre-processing, such as reducing the number of features in a data set or decomposing the data set into multiple components. There are different unsupervised algorithms used for clustering, which are K-means clustering, hierarchical clustering, and DB-scan. So it is mainly used in the fields of marketing and biology. Next, reinforcement learning. It allows machines and software agents to automatically determine the ideal behavior within a specific context in order to maximize its performance. Simple reward feedback is required for the agent to learn its behavior. This is known as the reinforcement signal. The best example of this is a game such as a chess, where points are maximized over multiple moves. In case of self-driving car, it interacts with its environment, and depending upon its performance, it reaches to destination safely. Conversely, the agent receives a penalty for performing incorrectly, such as going off the road, or the other examples are also there. But the advantage of this approach is that it allows an artificial intelligence program to learn without a programmer spelling out how an agent should perform the task. There are different machine learning algorithms which can be implemented in Python. One of that is linear regression. So it is one of the most supervised learning algorithms that observes continuous features and predicts an outcome, depending on whether it runs on a single variable or many features. We can call it simple linear regression or multiple linear regression. Next is logistic regression, which is a supervised classification unique machine learning algorithms, which can find its use in estimating discrete values like 0, 1 or S, no or true, false, and based on the given set of independent variables. Next is decision tree. It falls under supervised machine learning algorithm in Python and comes from use for both classification and regression, but mostly the classification. Next is support vector machines. It is a supervised classification, one of the most important machine learning algorithms, and it plots a line that divides different categories of our data. Next is naive Bayes. This assumes independence between predictors, and this classifier will assume that a feature in a class is unrelated to any other. If you consider a fruit, then the apple, suppose, if it is a round, red, and 2.5 inches in a diameter, the naive Bayes classifier will say these characteristics independently contribute to the probability of the fruit being an apple. So this is even if the features depend on each other. So next is KNN. This is again the machine learning algorithm for classification and regression, mostly used for classification. Next is K-means. It is an unsupervised algorithm that solves the problem of clustering. It classifies data using a number of clusters, and the data points inside a class are homogeneous and heterogeneous to peer groups. Next is random forest. This is an ensemble of decision trees in order to classify every new object based on its attributes. Trees vote for class, and each tree provides a classification. With most votes will be in the forest. So like this. Along with this, there are different applications of machine learning. I'm not going to elaborate. I'll just give the names here. By name itself, you can identify what type of application it can be. So image recognition, speech recognition, traffic prediction, product recommendations. Then we have self-driving cars, email spam and malware filtering, virtual personal assistant, online fraud detection, stock market trading, medical diagnosis, automatic language translation, intelligent spam filters. There are so many others also, but I've taken here very few. I'll just take your leave by just giving the information about what is the difference between AI, ML and DL. So actually, artificial intelligence and machine learning based technologies are playing a crucial role in the response to the COVID-19 pandemic. And experts are using this AI and ML to study the virus, test potential treatments, diagnose individuals, analyze the public health impacts, and more. And therefore, it is necessary for us to know what is this AI, ML, and deep learning. So actually, this deep learning is a subset of machine learning, which is a subset of artificial intelligence. And AI is any computer program that does something smart. It can be a stack of a complex statistical model or if-then statements. AI can refer to anything from a computer program playing a chess to a voice recognition system like Alexa. And machine learning is a subset of AI. So the theory is simple. Machines take data and learn for themselves, and machine learning systems can quickly apply knowledge and training from large data sets to excel at facial recognition, speech recognition, object recognition, translation, and many more other tasks. So machine learning allows a system to learn to recognize patterns on its own and make predictions. And contrary to hand coding a software program with specific instructions to complete a task. And all machine learning counts as AI, but not all AI counts as machine learning. So this deep learning is, as I said, it is a subset of machine learning. Deep ANN are a set of algorithms reaching new levels of accuracy for many important problems, such as image recognition, sound recognition, recommender systems, etc. It uses some machine learning techniques to solve real-world problems by tapping into neural networks and simulate human decision making. So it can be costly and requires huge data sets to train itself. So this is because there are a huge number of parameters that need to be understood by a learning algorithm, which can primarily yield a lot of false positive. So with this, I just conclude. Deep learning is an advanced form of machine learning, which comes in handy when the data to be dealt with is unstructured and huge. And thus, deep learning can cater to a larger cap of problems with greater ease and efficiency. And there are so many technological breakthroughs like Google's DeepMind, which is the epitome of the heights that current AI can reach, facilitated by deep learning and neurological networks. So thank you so much. With this, I'll stop. If you have any queries, kindly mail it to hodit@jnec.ac.in or hodUDICT@mgmu.ac.in. Thank you so much.
Thank you, ma'am. Participants, any doubt, questions?
No, Madhuri, we'll take it on the mail because already it is late. So I think we'll start the second keynote. Yes.
Okay. Thank you, madam, for your detailed explanation of machine learning, its classification and application has brought us a better understanding to the subject. I feel very honored to introduce a distinguished person to the audience, Dr. Krishnan Umachandran, sir. Dr. Krishnan Umachandran, sir, is the General Manager at Nelcast Limited in India's largest cast iron foundry, who is continuously learned by attempting experimentations, innovating and networking. Sir has completed his Bachelor's of Mechanical Engineering from University of Madras, Masterate from Technological Operation BITS Pilani, Post-Graduation Diploma in Personal Management and Industrial Relations from Madras School of Social Work. Sir has also been awarded a doctorate degree from Dr. MGM University. His personal strengths include market and customer, leadership and management. He was appointed as Assistant Manufacturing Engineer, English Electric Hauser from 1988 to 1990. He also acted as maintenance depot in charge of Southern Railways Madras Division from 1990 to 1995. Sir was also appointed as Assistant Manager HR in Hindustan Motors Passenger Cars in 1995. He was also been acted as Personal Manager at India Pistons Automotive. From 1998 to 2001, he also worked as HR at Larsen and Turbo Industrial Valves, Kanchipuram. He also acted as Principal Consultant in charge at Armois Trust and ERP consultancy from 2001 to 2009. Along with industry experience, Sir has also experience in teaching and research at personal management and industrial relations, Madras School of Social Work, University Grant Commission, Academic Staff College, University of Madras, and Amrita School of Business, Coimbatore. Faculty of Information and Communication Technology, Makri University, Kamla, and Industry 4.0 skills. Throughout the value chain of production to marketing and beverages, pharmaceuticals, building tiles, footwear, medical and surgical devices, foundry, electricity, ERP, etc. Currently serving as General Manager at organization departments and guides the dispatch performance at EBDTA, India's largest grey and SG iron foundry. So without further delay, I request Dr. Krishnan Umachandran sir to address the audience with his valuable inputs on human-machine interface with deep neural network. Over to you, sir.
Oh, thank you very much. I hope you people can see my screen. If somebody can prompt, I'll start.
No, sir. No, sir. It's not visible.
Not visible.
Yeah, now it is visible.
Yes, sir, visible.
I just removed.
Yeah. You removed it and it was visible for a second. Yeah, now it's visible again.
Very good.
Yeah.
Okay. Thank you, Dr. Tamane, and to the MGM University for inviting me to give a keynote on this topic, Human Machine Deep Neural Network. Okay. I'm Dr. Krishnan Umachandran. I'm a general manager in Nelcast, looking after the function called Organization Development. I have about 35 years of industrial experience spanning right through many products which had been through my career. So this topic on which I'm going to talk to you, which is called as human-machine interface, has a lot of commonality of communication between a non-life and a life product, and in which you also have a kind of a neural network that is being connected between the human and the machine. See, before not making much of a time, I'll get into the content on which I'm going to talk so that you people can easily understand what it is. See, the coverage of my speech today is going to be on CPS, the cyber physical system, the environment, the AI, IoTs, and the architecture. The architecture of intelligence, which is going to cover neural network, learning, training, and computation. On this, if you see, we have about more than a decade experience in this field of Industry 4.0. We started getting on to research in this field somewhere in the year 2012. So many of the content which I'm going to share you is not going to be available in any of your textbooks across the world. So it is better you have a capture of it so that you can learn it in future. See, these are something which are still published or yet to be published. So these are very virgin in its characteristics. So you will be benefited if you can listen to it properly. And then in the end, you can ask me questions so that I can also share my experience on it, right? See, this is the first important part of our deliberation, which is called as the cyber physical system. Cyber physical system works more like any kind of a physical system or a machine or a device or a gadget or an equipment which is made to be connected with the cyber part. Cyber part is, it's not computing part, it is the connection between a computing and a cyber and a physical machine through a cyber state. See, machines are being available right from our skills and arts ages. That is even before the industrialization or industrial revolutions happened. right before the first industrial revolution, which is called as the mechanical revolution or the steam engine revolution. From that time, what happened was they had machines, like they had some grinders, they had some pulverizers, they had some plowing machines and many things. People were hunting and living on farmings. Those people, when they invented the machine, they had to spend a lot of energy and effort to make the machine drive. So that was the first point, like, in first industrial revolution gave the impetus of automation to these machines. When the steam engine was invented and the mechanical systems got into place, like you had leverages, linkages, cams and all, devices coming into place, making a transformation come into performance, this steam engine revolution changed by a century later. So, somewhere in 1800s, when the electricity was invented, and then you had more temperature can be evolved so that the cast iron was made into an alloy called steel, and then revolutions happened in the material structure, and the second industrial revolution went on improving the performances of the earlier version of machines. So the drives and energy, which was facilitated by electricity, was the second industrial revolution that still is being continued. Somewhere in 1955, when the semiconductors were invented and then computers came into place, the precision started getting on into the machines. When people started getting the numerical controls, the CNC computer numerical controls, and everything went on to have a precision node, then the semiconductor was getting its place into a physical machine. This is where we get the computing physical machine into place. Later on in 1983 onwards, when internet was invented, the physical machines, the computing physical machines got into a stage called cyber physical systems, CPS. Cyber physical system is nothing but you have a conduit of internet through which you are going to control the machine from a far state or a virtual place. If you look at the diagram which I'm showing you, IoT 1 and IoT 2, it's like a handset of a phone where they are on the listening part. An IoT of one machine can listen to another IoT of another machine and then make the interconnectivity, where the speaking part is the sensors and the transducers and the binary converter which energizes them to get connected. So every machine, when it is being connected with a sensor, and then the sensor has a physical node, and now it shows you a physical deflection. Sensors are many, like you have a pressure sensor, displacement sensor, temperature, proximity, optical, and many kind of sensors you have. And these physical deflections, when they are made into an electrical impulse through transducers, that's where you have a pressure identified through an oscillator or a flow oscillator or an inductive appliance or a photovoltaic transducer or a piezoelectric. Like that, when you have different transducers, then you have the electrical impulse coming. That is, you have a physical deflection converted into an electrical. Now, the computer cannot understand the electrical impulse. It has to be converted into a binary form. That's where you have a binary converter before you feed it into a computer. So the computing device works to be connected with sensor, transducer, and binary converter, which is otherwise called as IoT. So these IoTs speak between the machines and they give you a kind of a signal for interconnectivity, also takes care of the correctional signals between these machines. So machines are now connected. But to connect all these things, you need to have people. People, again, can't become very smart when we are going so much sophisticated. So we need to identify people who is doing what with the machine so that we don't get into our problems later. Like right from the photographs and usernames, passwords, many kind of unique identifications have been identified. Now, in addition to the biometrics or the fingerprints or the iris detection, facial recognition, now your sweat is also being identified as one of your unique identification. Tongue print is also there for unique identification. So the cyber physical system, a physical system connected with internet and then through the simulating part of your IoTs is called the one which is going to change the pro rata of running in this economy, which is called the Industry 4.0. Going further, see this environment for cyber physical system, it's not only on the physical machine and the cyber state and the internet, it is going with the IoT. IoT now you need to identify what is that the sensor in the environment is going to do. See, when you want to have a connectivity of a sensor, then means you want the machine to become intelligent. That is why you sense something. So when you want to become intelligent, the machine also learns. That is where Dr. Tamane has told about the machine learning and deep learning. See, to further improve or improvise on that part, this is called an auto-response reaction, which the machine gets, which is called machine learning is nothing but a user-defined sensor output. Whereas the deep learning is called a user-dependent sensor output. See, user-defined is, see, for example, you have a lot of gadgets at home or in your office. You enter your office or your home. When you enter, the lights get on because there can be sensors which can identify a proximity, physical disturbance to the environment. You can get the lights on, and you can have your aircon also on, or you can have your audio system or your television sets and many things to be on. But in a normal thing, the machine learns that how much of volume you keep, how much of a display levels you keep, or temperature you keep. Everything the machine can understand because it is going from a series of learning that has happened. But now what happens is the user defined is, for example, you take your air conditioner, you enter into your room and the machine switches on, and it checks the room temperature along with the outside temperature, and then it gives you an output. For example, around 24 degrees or 25 degrees it gives you. But on a particular day when you are not well, the same temperature will not suit you. That is where the user dependent comes. That is the deep learning. So the machine now understands from you what you are suitable to take. It is not 24 degrees or 18 degrees. So it needs to increase that temperature. That is somewhere around 26 plus, making it 27 or 28, so that you are comfortable in that atmosphere. So user-defined functions are sensor-driven IoTs, which are ML state, the machine learning state, and user-dependent are called as the deep learning state. So how we do what we do is that we are going to talk and see during this session. See, intelligence, machine, when it becomes equivalent to a human being to gather information, process it, and make quick decisions, it works on a lot of data. Of course, it takes into consideration a lot of previous experience, and then it scales up or reduces or alters the thing. So the intelligence comes. But if a machine becomes intelligent, it should also match to the progress of a human being, because humans can throw away a content which at any time they may say it is not okay to them. So a deep learning is one which is an extension of a machine learning, but it is similar to a neural network. Neural network is like a brain. We have our brain tutored to a certain extent with a lot of data. Every individual has a certain amount of data and everyone is unique. Similarly, a machine will also be unique to the data. So we need to identify how much the machine has to take the data, which here in Industry 4.0, we call it as a big data. So the sensory information, which is artificially promoting this activity, is related to biosensory or bio-human sensory inputs, which is your speech, sound, taste, touch, whatever it is. So all our biosensory information, which is making us live, and a machine which is non-alive is to be equated together. So a lot of inputs that has to be processed during this activity. So what are those sensors? Sensors are many. See, the more important part in a human being is the eye. If you can identify the eye movement, the analyzation of the perceptual process, the attention control, the cognitive controls, the appropriate processing you can identify from a human being. Similarly, a machine, when it can go through you and identify the ocular movements, then it has a superiority of its presence. Then comes the encephalogram. Encephalogram is like, many of us, when we see something and we react to something, our brain will be in some other place. So we need to also have a machine which can look through these thought process and information. Then this is the thing which can make a machine superior to its function, which is called the EEG or electroencephalogram, which is a deep sensor. And then we have the dermal analysis. Dermal analysis, even in your lie detector, the police use for identifying whether a person who is being convicted, whether he tells the truth or lie. Because skin is the one which can go with galvanic actions, because when you like something, your skin cannot tell the lie. It will tell you the truth. So if you can identify what happens on the skin or the emotional reactions of human beings, then EDA is a one which can give you a better part. Then the facial expressions, the facial muscles, which is called the electromyogram, where if you can read through these gestures, the choices, the facial movements, then you can give a better part. So these 4 parts of a sensors of a deep learning are more important for this. If this is to happen, what is more important is your IoT architecture, because you have a lot of machines giving out a lot of signals. When machines speak out, they give a lot of signals, then the sensors have to capture it also. It's not only emitting from one point, it has to be captured. So it can have a lot of networks like radio frequency or your near field communication devices or your Bluetooth or your Zigbee or whatever network on which you get this data passed on to a sensor. Then means it has to be sensed properly. Of course, the noise should be avoided, and then it should be communicated through a network, which can be a long range wireless wide area network or a low power wide area network. See, when it is long range, normally we have the Wi-Fi going with the long range part and the low power is going through the cellular part. But you cannot have expectations that everywhere you will have this wire low power or the long range. So these things, when it is being captured, it has to be fed into a cloud fog edge kind of a communication. As a cloud is where you have it at a far place, fog is in between, and edge is on the machine. So if a computation can happen on the machine, it is called as edge, and it can happen at a far away place, it's called cloud, and when anything in between, it's called fog. So this is being transmitted to a IoT server, which is called the MQTT server, MQTT server. So this, if it is to happen, then means the network is the more important thing to get the data passed on to a machine. See, these long range wide area networks are good for sending out data from a node to a gateway or forward it from a data to a server. But when you want to have a cellular IoT, what happens is 5G can take a connectivity of all IoTs. Also 4G can take. But there's a lot of things called narrow band IoTs, which are an unlicensed spectrum, which is now being used by Huawei. Huawei is the Chinese military operated organization, which Vodafone is trying to buy it so that it is not free, and so that they can pick it up across the world. See, these two have to be clubbed together, which is called the hybrid networking. If you want to have a WAN, wide area network, connected together, which is called the hybrid, then you need to have a network function virtualization, NFVs, or a software defined networking, so that it can make it available faster and smarter. Why 5G is more important for a deep learning? Because 5G works on a speed which is much non-compatible or competitive to the existing paths. See, 5G is on theoretical means it is a 10 Gbps, whereas 4G is about 1 Gbps, or in reality it is somewhere even claimed as 50 Mbps. The other things of 3G and 2G, you have to forget it because it may not suit for a transaction of a deep learning network. Even if a service provider claims 5G is going to give you 10 Gbps, on an average, it gives you only 4 Mbps. And when it is being tested, it is still more or less, it is 264 Mbps. On an average, it is only 72 Mbps. So there's a wide difference between what is claimed by the service provider and what is finally obtained. If 5G itself is having this kind of discrimination, then 4G you can expect to be much far below. So the better part is you do a spectrum sharing, which is called a time divisions and a frequency division duplex, which can be a frequency spectrum. You get it together and then share so that the deep learning can be of a better use. So the IoT architecture required for this kind of a deep learning is to have these RFID, NFC, BLT, and Zigbee sensing data being reached to for a sensing communication through a NFV and a SDN through a common connectivity, which is called as the hybrid, then reaches your MQTT server. If we have this kind of infrastructure in place, then the IaaS, the infrastructure as a service, can be propagated through your cloud, and it can be envisaged through fog or edge. So a better clarity of communication dependency can happen. This part is already explained to you by Dr. Tamane, like on the machine learning. But anyhow, I'll give you a kind of an introduction and then move on further, because without knowing what is ML, you cannot get into DL. See, ML is where the machine is automatically learning. It is not you are pushing it. The machine is learning. How it is learning? It's like, we would have studied integration, differentiation, binomial series, and many things where you would see a series where a function tends from 0 to another state. 0 means off state to another state, maybe 1 or 2 or whatever it is. It's an on state. So there can be many incremental values in between. Incremental values are the ones which is learned by the machine, which is called as machine learning, for which you need not explicitly program. For example, even when you close your system and open the same application, the system shows this is the place where you left. It means where the system is watching you. It means the machine learning is happening in your system. So applications of Microsoft is already programmed with machine learning. And even if you go into search for your Facebook, some of your screens will repeat same posts, sponsors, programs will keep repeating. That is where you have exposed yourself more time to a particular thing. So the machine learns, oh, this guy is presenting himself more, that means he is interested in this more, and so he requires this kind of an input more. So machine learning is picking up what we are doing, and it is trying to put on it onto us. This is called the linear perceptron. See, it is on a one variable or a one parameter or a few parameters. So this is where we have the flow called interactive features data mining chatbot. Interactive means machine cannot give any other part other than a graph or a map or a chart. So when it gives a graph or a map or a chart, what you can do, you can either model it, change the timings, or change the users, the deployment part. This is the features. Then the data mining is already structured like, you have algorithms. Algorithms are nothing but a kind of a formula. Uses a lot of hyperparameters. Classification regression is where you class together or separate things together, have a time series, connectivity with time, cluster analysis, mix people or groups together, and then anomaly detection. Wherever it is error, you remove it. Finally, goes with your chatbot, which is your voice or text. Like Amazon has a Alexa to do it, or Google has an assistant to do it. All these are all chatbots. So this is where the machine learning comes. For this machine learning, already Dr. Tamane has briefed you on these algorithms. So I'm just going to leave it. But I wish to tell you people that if you can pick any 2 or 3 of this and you master on it, you have a livelihood of your employment, because ML is going to be alive for another 30-40 years. So this is a good important point where you can pick up your skills and work. But everything is not on a machine learning. See, human beings have the senses. Machine doesn't have a senses, but though we are going to put it onto it to learn it. We can see, we can speak, we can smell, we can sound, we can touch, we can taste. And these are all not separate in silo. When we speak, we can smell. When we smell, we can hear the sound. When we sound, we can also see. And if we are near to it, we can feel it. So there's a combination of many of these parameters, which is the one that has to be fed into your artificial neural network. That is the ANN functions with multiple layers of network. So human being, to get akin of and a replacement to a human being is not as easy as we think. But the probability of getting on to creating an artificial human being is where we are trying to push. Even now, we have a lot of sensors being used in food and flavor industries for tasting. There are chemical sensors, microbial sensors, pH sensors, titration sensors, and all those stuff. That's all working on for this. So this is a kind of a complex scenario on which deep learning comes. So to learn this, what happens is we are now getting on to the deep part or human interface part. See, we have brain. Every one of us have a brain, and every one of us have a past experience, which is called the learning that has gone into us. Then at certain times we say, okay, our learning is wrong, and then we train ourselves. We go for a change, the training. And then based on that, we improve our capability or capacity of us. Like this, the machine has to go on. So a machine has to do the right thing. It should not do the wrong thing. And at times when it is required, it should also go on for escalating its performance or give a thing which is much more than which is required. So a machine, when it is to go in for this kind of an architecture, what happens is you need to go on with making it learn. Like how we, in a younger age, when we get into schools, we do a lot of learning. Though at, even in a child state, our knowledge levels are good. See, we do a lot of activities, we do a lot of adjustments, and we do a lot of applications. In other words, in a simple term, it is process. We do a learning process. We do a lot of mistakes, which is error. And then we try to use something which is appreciated by our parents or our teachers and things. This is where the learning comes. So when I wish to give you an analogy rather than getting onto technical, because technical things you can learn, but you should know the analogy where to use what. Because we are putting up a factory, Industry 4.0 factory in our company, and we have gone into a lot of information age being used, with a lot of IoTs being placed, artificial intelligence coming into place, and a lot of automations getting connected through the internet, which we call as Industry 4.0. So the first part which I'm going to teach you is called the supervised learning. Paired inputs was that which is required versus a desired output. See, when you know what to be connected together, classified together, if it can give you an end result, this is called a supervised. This is where the supervisory learning has to go. So what to be clubbed? You should not club something with what is not required. You cannot club a shoe with a broom. You cannot club with a socks with a kind of a sofa. So you need to know what to be clubbed so that the machine can learn, okay, when I look into this, I look for the mating part. Then the pairing happens. So similarly, even in our schools, we study languages together. We do maths and science together. We do history and geography together. Like this, there is a pairing kind of an input so that a desired output can come. So this is the process. So if an error, if you do a supervised learning, what is the error technique? Error technique is your mean squared error. If you do a supervised, you need to go for a mean squared error technique. And what it can be applied with, it can be applied for handwriting. If you want to measure analysis of a handwriting or a speech or a gesture recognition, then you can use supervised learning. For other things, you should not get into supervised. The other thing is, like, see, every time you cannot be taught. See, for example, you are left in a ocean or in a forest. There, you cannot be taught this is the way you have to go. You will be having a kind of a model. You may have a compass and a chart or a map. So based on which you have to find out your way. So this is a different way of unraveling things through using our computing techniques. This is where we go on with models, where which cannot be coded can be modeled. So the modeling part works on a priori assumptions. Like, you go on with assumptions like this is the way, if you go, it's north. Okay, then means you go. So this has been proven, but it is there. You will not have a teacher to teach you, which is called unsupervised, where the error correction can be used through compression of mutual information, filtering, statistical distribution, which can be estimation, posterior probability clustering, and all these things can be used for minimizing your error. See, it's not only supervised and unsupervised kind of a learning which we learn. There is something which we learn through reinforcement learning. For example, you are cooking. When you cook for the first time, you are sure that you will not get what you want because you don't know. You are testing yourself. The color may go wrong, the flavor may go wrong, it will get burnt, you will get burnt. Many things can happen. So these are called agent, a string of actions. Similarly, in your problem, if you have a string of actions which is connected to an environment, then you use for error correction Markov's decision. So this is where reinforcement learning comes. So a reinforcement learning goes with agent, environment, and Markov's decision for environmental corrections. So like this, when you go for the last part, which is called the self-learning. See, every one of us would have gone in our childhood to drive a bike or a cycle. We don't know when we will fall, but only when we fall, we learn. This is where one situational input leads to one output, which is unique to every individual. There you don't have any advice, you learn. Similarly, when your problem has, it's not a supervised, it is not unsupervised, and it is not a reinforced, then you do some trial and errors and iterative corrections using crossbar adaptive array. And this is where this tool helps you in identifying the error loss into it. So these are the four formal tools of learning which is available for deep learning. So you can pick any of these styles and master it. But straight away mastering is not possible. I'll tell you what are the products available in the market so that when you pick up in a product which is available for algorithm learning, then you can pick which style will suit you where. See, this is where the training comes. Training is specific. See, every one of us go to school and learn, but each one of us pick up a different skills. This is where the training. See, our brain is picking up something which is being interested for us. So, and we learn out of it. There's a lot of perceptual learning rather than the real intended learning that goes on. A machine cannot do like that. A machine will be taking only what you are giving. So you should be in a position to give what it is required for learning. And this pre-trained transformer, I'll talk to you later because this is another subject. But I'll close it up before I finish my talk on this. See, the DL networks have a feed-forward network or a multi-layer feed-forward network. See, if you have a feed-forward, it's a contributor, hidden, and output layer with no impact between units and no feedback. So it's a fall-free. It's a one-way kind of a communication. If it is a multi-layer feedback, it means it has a back propagation. That means it takes care of your memory, your experience, and goes with your complicated decision boundaries, Boolean functions, and you can remove your errors through multi-layer perceptron. But when it is a linear one like a feed forward, it contains many stages with units linked in feed forward mode. It's either fully or locally comparable layers, and it influences each of your layers. Whereas in your feed forward, what happens is you learn from building an arbitrary and you go on computing errors on an iterative mode. See, this can be better explained when I go in for my next kind of slides. See, this is the neural network. Here we are going to bring a brain which is akin to a human being, but human brain cannot be obtained into any machine unless for what a machine is expected to do. So there are many networks like artificial, convolutional, recurrent. You have generative adversarial, deep belief, and long short term memories. Okay. But for now, I'm going to restrict with the first point called the artificial convolutional recurrent network. See, artificial network is nothing but, see, when you get into a initial learning in your childhood, when your teacher shows you one input and asks you an output, you will have to place your hand in the same input part. Like that, here you have a lot of neurons. Neurons are connected through nodes. So the connecting point is node and the neurons are connected together. So in an input stage, when you're going to show an image or a document, what you expect is your output should also show an image or a document. That is what is the basic thing of an artificial neuron. So whatever you're showing in should be shown out. If it shows something else, then means that your network is not proper. So the inputs of any external variable, which is an image or a document, which is being connected through the neuron, can go through a feedback mechanism, which is called the back propagation. And it will check every time a neuron touches another neuron through a node, and it will say, OK, I'm right, I'm right, I'm right. And then it falls and shows out something which is called an output stage, which is also the same recognized object. This is the basic part of an artificial neural network, for which you have a lot of algorithms to be processed, which we will pick up later, or it's completely in a higher level of input that needs to be given to you. Now coming on to the convolutional neural network. See, you don't get everything on one part. There'll be a lot of groups. There'll be a lot of things which are covered, which are hidden. So a dog or a cat, when you see in a 2D as a single, is not the same when it is together. So convolution means one form is changed to another because of its association. Even Dr. Tamane was telling you about the vectors being used for calculation. This convolution doesn't go with vectors. Vectors is nothing but matrix. You cannot use the normal general matrix here. You have to have an operational model of mathematics being associated, not only to cover your pixel data, what you see at what point in your screen. It goes on further for image recognition and processing. This is where the convolutional neural network comes. I'll give you a better reasoning for easily understanding what is convolutional neural network. See, for this, what we have is called a bipartite classifier. See, when you want to have classes created, see, machine can pick something when it is 1 to 1. For example, there is an input data, and then each of these input goes with a lot of features. For example, you have a data which is called some dogs or cats or horses and donkeys, something. You classify it together and then you can remove it. You cannot make a lion which is having 4 legs and a donkey which is having 4 legs, or a cat which is. So you don't complicate the things for a machine. Let the machine learn it simple. So when you have classifiers done, then you go on with different feature sets, which is called the color, size, weights, and etc. And then you categorize them so that they differentially learn from each of these data, this is called the bipartite classifier, which the machine learning or deep learning can handle. So you should first understand how to use a bipartite classifier. And here is the position where you can have a loss function. If you do an error here, you can quickly control it and learn out from it so that the machine comes friendly to you. How it does? See, first you take a picture or a video or whatever it is, you identify the object. And once you identify the object, you need to have the object detection. The machine should also identify that is the object. Then see, it is a one-to-one kind of a relationship. But in a real life, you cannot have the objects excluded or separated. So it will be together with something which is called the instance. So you need, in any instance, you need to classify them and then create the CNN or a convolutional architecture. How you do? You do the transformer training. That's where the predictions comes. So you take each object, one object at X coordinate where it is, Y coordinate where it is. You're going to train the system. So then you take another object where it is, where it is. And similarly, you list down where and all your objects which are to be trained by the machine is being classified. And then you do a bounding box. And you also get a null object to it where it is not there. There it need not go and search. So the machine is being now got into a kind of a classification where it is to look into and where it need not look into. Then you do the ordering of the object, where it is visible fully, where it is partially visible, where it is not visible, where it is overlapping, where its tail end only is seen or its face end is seen. Like that you do an ordering part and then you do a bipartite matching loss. So this can be excluded, this can be included. All these kind of a programming part can be done, so that you create more channels for evaluation, which is called the multiple objects of same class or multiple objects of different class. You have different sizes or overlapping or visible partially or differential orientation, etc. This is called CNN simple architecture. So if you do this, then the algorithm can go on with looking into your data and then it can process so that you get a artificial intelligence being into place. The last part now is the recurrent neural network. See, everything cannot be done on a current stage. That goes on with your backward propagation. You learn from something which has already happened. That's called the hidden stage. See, for example, if anything has happened in your previous part, then means it is your past experience and it is not shown unless you are asked to do it again. So this becomes hidden. So your current state, HT, is a function of your previous stage, that is HT minus 1, and your current input stage, which leads to your recent experience, which is the new hidden part, which is the trained part of the machine. So you will have a multiple fixed activation units, which are based on your past experience or the past knowledge, and it changes with time. And this is being implemented to the machine, which is called the recurrent neural network. So coming on to this, let me stop here on the frame, kind of a training and get into where it can be used. See, machine learning is different, where it goes with all your algorithms of your polynomial algorithms, whereas this deep learning goes with a lot of abstraction. It is not clear. So when you want to have a lot of abstraction, that means you need to have a generic functionality. It's not a structured functionality in use. There are many products which are available like Scikit, Theano, TensorFlow, PyTorch, Keras, many things are there. I'll just give you an example of where you can pick and what for. Like for example, Scikit, if you want to have, you work on only models or sequence. Then you can work on the predictive data analysis, which is accessible and reusable. See, Scikit has a foundation, kind of an input like NumPy, Matplotlib, you have SkiPy, and many of these foundations which are useful for creating your models or your sequence predictions. This is an open source program which is used for graphical interfacing, and it predicts a lot of scenarios so that you can use this point on a basic level. But the next level to it is the Theano. Theano, though it is all modular, but it is used only for defensive checks and debugging, and it is not taken more because you cannot take a printout of this product. So this is the discriminating factor of this Theano not being much taken into. But the next one, which is called the TensorFlow, is gullible for being picked, which is called the data flow or differentiated or auto differentiation. It uses a graphical processing unit, GPU, and a multiple node, and it has a pipeline of deep learning. That is the ETL. You know, you can extract, you can load, you can transfer the data. All these things are now RDBMS. So when you do on this for a free flow of a source, the machine learning learns and it generates a lot of graphs and features. You can even code it on a C++ or a multi-threading, and then you have a device efficient operation. So this is where the TensorFlow comes. Then the Python-oriented PyTorch. PyTorch, it coexists with support, it can go on with code as well as on modeling. Whereas see, certain other areas, you cannot go on coding. You can go only on a model. Whereas PyTorch has both the effects, and it is again an open source. It is completely, it can go with different speeds. You can work, and you can use a production process prototyping through your Python library, ML library. You can get it, and it does a lot of computation, and it's GPU supported. It has a better hardware efficiency, consistent to debug. So this PyTorch is one of the better tools available in the market. The last part is Keras. Keras is a hybrid of Theano and Tensor. The positive of Theano and the Tensor is together here in PyTorch, which is a Python API, where it has a high level, it has a library which is real time and data augmentation and callbacks, and it can help bridging both the use of Theano and TensorFlow. If you think you want to learn Theano or TensorFlow, better stop it and get into Keras and touch base on Scikit and PyTorch so that you can learn it. See, if as a computer science engineers or graduates or faculty, if you want to go further onto your improvising your employability skills, pick any of these things or one or two of these and function experience on it, you will learn a lot. So now comes the last part, where this deep learning can go. Deep learning can be applied in all parts of your Industry 4.0. It can be worked on your simulations, it can be worked on your systems integration, it can be on your cloud, cybersecurity, additive manufacturing, augmented reality, big data, IoT, robotics, drones, etc. To understand or keep this in memory, you just remember this acronym which I formed: 2S, 2C, 2A, BIRD. 2S is simulation, systems integration. 2C is cloud computing, cybersecurity. 2A is augmented reality and additive manufacturing. BIRD is big data, IoT, robotics, and drones. So 2S, 2C, 2A, BIRD can take all your inputs on deep learning, and it will master up your artificial intelligence into the system. Okay, with this, I stop my talk. Thank you. If you have any clarifications, please ask.
Thank you, sir.
Dr. Tom, yeah.
Participants would like to interact with Dr. Umachandran, sir. If you have any doubt, you can please ask.
Okay, if they don't have, they can send me a mail. I have no issues. If they can talk, I'll be really happy to listen to them.
Okay. So you can post your doubt even in chat box also.
Yeah.
Thank you, sir. I express our sincere thanks to Dr. Krishnan Umachandran, sir, for your valuable inputs on human-machine interface with deep learning neural network. Sir has also explained in brief about deep learning by giving real-time examples. We hope that participants enhance their knowledge with the real-time applications and the experience you shared, sir. We also thanks for motivation and kind support towards us. Thank you, sir.
Thank you very much.
Dr. Umachandran, sir. Sir, participants have posted the question.
Can you read out what it is?
Can Keras software will gotten free?
See, everything you cannot get free. The Theano and TensorFlow are both are free, but Keras is a paid software, because it has the inbuilt opportunity for getting the benefits of both the Keras and the Theano and Tensor. It's not free. Initial things, all the software developers give it free so that people can learn out of it. But later stages, no one can, give you something continuously. See, for the betterment, what you people do is you get into a thing which is available free. Like you try TensorFlow first now, and then along with it you do the defensive checks along debugging with Theano, and then you pick up Keras. Don't buy Keras right away. First experience yourself and then get it. Okay.
Thank you, sir.
Anyone
Any
else?
more questions? No, sir, there are no further questions.
Okay, thank you.
Now we have with us today's another keynote speaker, Dr. Varela Lakshmi ma'am. Dr. Varela Lakshmi is an academician with 15 years of teaching and 8 years of research experience. She had completed her bachelor and master of technology in computer science and engineering. She had pursued her research in medical image processing under Visvesvaraya Technological University, Belgaum, Karnataka, and contributed towards detection of malignant tumors at a very early stage. She has more than 20 international journal publications and 5 patents to her credit. The Research Excellence Award she got, Research Excellence Award, Research Paper Award, Academic Excellence Award, and few awards she has received for her work. Dr. Varalakshmi has contributed as guest editor for Springer Journal titled Systematic Artificial Intelligence. Being a passionate researcher, she has involved in several real-time project development in machine learning, artificial intelligence, and image processing. She has been invited as speaker for several international webinars, workshops, and international events. She is currently working as Associate Professor in the Department of Computer Science and Engineering at Cambridge Institute of Technology, Bangalore, India. The lead role in the planning, organizing, and executing international project competition event titled as Seed Brains, involving more than 2,000 students across 30 different emerging colleges from various states. So without further delay, I would like to request Dr. Varalakshmi ma'am to deliver a session on the role of machine learning in healthcare. Over to you, ma'am.
Yeah, thank you, ma'am. Hope I'm audible.
Yes, ma'am, you are audible.
Yeah, thank you, ma'am. And yeah, let me share the, yeah. Okay, hope my presentation is shared. Is the presentation shared?
Yes, ma'am, it's visible.
Yeah, okay. Thank you. So good afternoon, one and all. First and foremost, I wish to thank MGM University for the wonderful opportunity being provided to share my knowledge about machine learning. And secondly, we had wonderful sessions by Dr. Sharvari ma'am and Dr. Krishnan sir. A beautiful insight on the basics of machine learning, deep learning, and how well it can be used in industry with all real-time, applications and discussions. So, in continuation to the sessions, I wish to highlight upon one specific domain, namely healthcare, wherein machine learning plays a key role. So nowadays, healthcare is a major domain wherein they expect a lot of support from machine learning. So how machine learning supports healthcare and how, like different stakeholders are being benefited through machine learning in this domain. That is something what we are going to, see for the day. Fine. So let me start with few applications what we people are already aware of. We know, like we keep using it without knowing machine learning is something at the back end which is playing a key role in this. So first and foremost, it's a smart records. Many of us would have experienced this. Like by chance, if you have gone to an hospital, okay, for some emergency or critical scenarios, or if you have taken our parents or elders, it so happens nowadays in multi-speciality hospitals, they expect us to immediately, sort of download an app or get connected through a medium in your mobile phones. So what is happening is when we step into the hospital, they take down all our data, they store the data, and finally at one point of time, might be within few days or something, it so happens like we need not even visit the hospital, staying at home, we are able to visualize the data, right? We are able to browse the data through our mobile phones. At times, we even get prescriptions from the medical experts through our apps and the mobile phones. So this concept is nothing but your smart records. So what is happening is is going to be available in multiple places, right? And it is going to be analyzed at the back end, and it is going to be processed. So what happens is the data fed in one particular system, it is going to be processed and it's going to be available experts as well as the patients, especially in the case of critical situations and with elders. So what happens is frequently they cannot visit the hospital. So there are so many. So what happens is these data, this way of processing the data is going to literally bring the expert to home in a virtual manner. It's not going to be in a physical manner. So that is something smart record means. All of us are using it. Only thing is we are not much aware that machine learning is something which is, completely at the back end, which is driving the whole thing. Similarly, the next common thing all of us are aware of again is the medical imaging and diagnostics. All the CT scans, the PET scans, the MRI, everything. Nowadays, it's completely driven by machine learning. And I'm going to concentrate more on medical imaging and diagnostics in this presentation. So let me just give a gist of it and we'll move to the next application. So here, if you see the ML, the machine learning models, okay, multiple machine learning model, it is going to help the experts. It is going to be like a friend for the experts to support with respect to the diagnosis. So they get almost a strong, a confidence, a strong opinion that whatever diagnosis they have made is also correct, almost like a double checking which happens over here. And that is the purpose why we go for, machine learning models with respect to medical imaging and diagnostics. Again, machine learning comes into picture here. Next one is drug discovery and development. This is another important area where nowadays ML plays a key role. So when we see the drug discovery, it's like actually the basic molecules, the drug molecules, it has to adhere to the human protein. In the human body, we have protein, wherein that adherence is very important. If the drug chemical composition doesn't suit our protein bodies, then it's going to be. Suppose a person is diagnosed with a particular disease. Earlier, it was like very difficult to identify an appropriate drug which is suitable for the person without creating any side effects or without affecting the person's health condition. So nowadays, it is really easy, wherein we have our machine learning models. It is almost like a combination of chemistry and machine learning. So the chemical drugs, the composition, the molecules, the various things over there, we are trying to map it to the biological part. So wherein the proteins, all the compositions in the human body, how are we going to match it and how are we going to find a suitable drug? So even if a new disease has been predicted, nowadays it's going to be comparatively easy to identify the suitable drug. So again, here machine learning plays a very major role. Next important thing is treatment and prediction of disease. Is to some extent it correlates with the smart records what I spoke just now. So what happens is once a person has been diagnosed with certain symptoms, all the symptoms are going to be recorded, and based on the symptoms, sort of prediction is going to happen, and immediately the person is going to be prescribed with what sort of treatment has to be taken ahead. So if you see here, what all I just scrolled up, it's like all these applications we know. Literally, we have experiences. We have in our mobile phones. We have in the apps. Everywhere in and out, we see this. Only thing is we are not aware of the fact, or might be to some extent we are aware of the fact that machine learning plays a key role. So how machine learning is used in all these particular applications, and especially in the field of healthcare, is something what we are going to see for the day. Yes. So as I told, let me touch upon the most critical aspect in the healthcare domain, that is medical imaging, because Medical imaging is something where everything starts with. A person is going to be diagnosed with a disease or a problem only after certain medical diagnosis. Thereafter, the treatment, everything goes on. Even our apps and everything comes into picture only after a person has been identified or diagnosed with a particular problem. So medical imaging, how it is used, or rather ML is going to be used for medical imaging in healthcare. So why we go for medical imaging, or rather what is medical imaging in healthcare? So first and foremost thing is we are trying to visualize a human body through several technologies. So why we go for making use of lot is mainly to diagnose the diseases and the disorder. Next important thing is to have a check on the medical condition. Whatever, if suppose if we have some historical problem, okay, some continuous problem. So what happens is we can try to store our medical conditions and we can easily monitor the basic checkups like our BP, the heartbeat, the pulse rate, oxygen levels, all these things we can try to keep on having a monitoring check, and it's going to be easy for us to predict, things which might happen in future. So a sort of caution to be careful in certain things. And third important thing is mainly we go for medical images to treat the medical condition. So it is not just diagnosing and monitoring, but also through the various data what we have collected, it's going to be easy for experts to provide the treatment for such medical condition. And next important thing why we go over here is for non-invasive test. Gone are the days wherein patients are going to undergo rigorous test. It so happens that the taking up the test itself becomes very painful for the patient. So it's quite simplified nowadays. So they need not undergo rigorous test in order to literally identify what type of disease or problem they have. And as we all know, we have various types of medical imaging procedures. And nowadays it's called a earlier it was called like X-rays or MRIs and ultrasounds, but now it is like medical imaging procedure. Why it is called as medical imaging? Because we are going to have our back-end support over here. The moment the MRI scans are being taken, as far as we have seen, the experts or the clinicians are going to provide you the result. They'll be providing you the report. So it's not like compulsorily an expert and a doctor or a medical expert has to analyze that particular image. Your model, the machine learning model, analyzes images, and the machine learning model provides the first-hand report of that particular data over there. So all these procedures comes under your medical image processing. And so as of now, we have seen what is medical imaging. Next one is what is medical image analysis. So in analysis, as I was mentioning till now, we are trying to process the images. It is not just collecting the image, okay? It's like processing. We are going to extract the data from the image and apply certain algorithms and techniques as mentioned in the presentations. We are going to literally apply those techniques, several algorithms and approaches, and we are going to process it and come to a particular conclusion. So we are able to interpret, we are able to come out with some quantitative results from the data. That's why we call it as medical image analysis. Only thing what is very important over here is, as Dr. Krishnan sir was mentioning, our prior knowledge is very, very important. That's why we seek the support of medical experts. So if suppose a problem occurs in a human body, the doctors know very well this is how that particular problem has to be treated, and this is how it will be, creating some particular problem. So with that prior knowledge, we will be able to pick out a appropriate algorithm in order to develop our model. So choosing the the key role when it comes to developing a better model. So that prior knowledge is very, very important when it comes to machine learning. Yes, and why we need to go for our medical image analysis? As I was mentioning all this time, it is going to support the clinicians. Here I've covered all the stakeholders. So medical experts, the various different types of experts again, basically with respect to clinicians and next level, next with respect to the patient. So everyone are going to get benefited through our medical image analysis. Yes. So this is the slide. It is actually my research work what I've carried out. It was basically detecting the malignant tumors at a very early stage, very, very early stage. And wherein I had observation like which particular stage of tumor. So that patient need not even get into severe test. They can directly, get into the treatment. That was a research area that I've tried to work on. So what happened over here is, if you visualize the left hand side of the images, you have some thing called as segmentation. Next one is detection of ROI. It goes on. I've just taken a middle portion of it in the whole processing. So in every level, when we try to apply the machine learning model, we have several steps. For example, segment is really locate. I have to the place where the tumor is existing. In the complete image, I have to locate where the tumor is existing. Try to identify where the tumor is, because having landed up in the tumor only, it will be easy for me to collect the features from that particular tumor, using which only my complete model is going to tell whether it is a benign one, a malignant one, or a normal tumor which doesn't have any cancerous symptoms. Visualizing here on the left hand side of the image is totally, I can tell it's just the basics. Okay, it's like a starting point. So here itself, if you see, we would have algorithm and approaches. We don't literally come to that exact location, identify the exact tumor with that appropriate boundary measurement data. Whatever I extract henceforth from this image goes wrong, and my model doesn't do the prediction. So mesh, it cannot be told like it's a single domain. It's going to have multiple things. Computer vision on the whole we can mention. So several things, whichever field falls under computer vision, your robotics, your big data analytics, everything is going to be having the functionality, means everything will be having the role of ML in it. So everywhere we can feel how the machine can be trained. Only thing is a type of data which is going to be used, type of the input which is going to be used, from where we extract the data, and then what type of data is going to be given to the model plays a key role. In the right hand side of the image, if we take, this is another healthcare application wherein the implants has played a key role. So the implants, if you see, the implant size and the measurement, everything has to be very appropriate in order to see to that the problem is being solved for the patient. Rather than, if suppose the implant size is not appropriate and perfect, obviously the patients are going to suffer over there. It will be either creating a pain for them, or it doesn't heal the fracture or the problem. So all these things put together, I've just taken two scenarios like this. We have multiple scenarios wherein ML models can be developed in order to do the prediction. So in the left hand side, if we see the detected region of interest, a tumor region, and from that, when I finally using my model, when I tell it is a malignant tumor and it is of particular stage 1, that is my final prediction. So my model has predicted, and it is informing the expert, telling like this is a problem, you try to give the solution for this. Similarly, on the right hand side, I'm trying to predict the measurements, total numerical measurement, the depth, the volume, okay, everything about the fracture, and then easily I can go for developing a implant. And nowadays, added on to this, we also have the 3D printing technology which is supporting the machine learning. So once the numerical values, everything is being given, we don't go for literally ordering for the implants. We come out with the 3D model. In fact, currently we are carrying out research in it in our institution. So the 3D model we are trying to develop, wherein through the model, it's like almost I develop a model with precise measurements and everything. So it's going to be more easy for the people who come out with that implant structure. So once I hand over this model, it will be easy for them to develop as per the measurements. So it is going to be very easy for the experts to handle it, and plus very much supportive for the patients also. Yes, so let me just browse through the three types of important scanning techniques which is being used in the domain, so that it will be easy for us to understand when I go to that ML portion how it is going to support over here. So three things what we have is CT scan, MRI, and the PET scan. So CT scan, as we all know, the results are from the CT scan. Okay, the results from the CT scan results, usually we make use of convolutional neural network in order to analyze the result, because when it comes to the scanning results itself, data is going to be voluminous amount of data, and every data is important. We cannot tell like I can skip few data. Basically, I mean here the features or the attributes, the characteristics from the image what I've extracted. So it's so voluminous, my CNN is going to support me by developing multiple layers and by developing multiple input nodes, okay, and easily it can process my data. But only thing over here with respect to CT scan is comparatively the performance, the results or the data an MRI scan, how it is going to support the ML model to derive the result. So it's like, again, if you ask me, it is like based on the situation. In certain scenarios, CT scan results, I mean, the data provides very good result. In certain scenarios, MRI gives the best result. So still research is going on in this area. Yes. So as I was mentioning, if we consider patients, if we just visualize from patient's point of view, MRI, it is going to present literally very less risk. Means they are not going to be exposed to very high radiations and all. But in CT scanning, obviously, it's going to be like high dose of radiation. And image analysis, what happens is it's going to be very quick when it comes to the MRI scan data than when compared to CT scan. The next important thing is a PET scan. This mainly it is used in order to locate any tumor or any particular, specifically a tumor in the body in any region. So externally, if through other tests, okay, other values, if an expert is not able to identify exactly where the tumor is, okay, the location in which organ the tumor is, or it is too small, they are not able to predict it, then the PET scan comes into picture. So one major concern over here is for the patient, they are going to literally, make use of a radioactive drug. The drug will be injected. That's basically called as a tracer. It will be injected into the patient, which will be traveling all around. It's like along with the blood, it will be traveling all around the body, and it will be locating the point wherever the tumor is. It will get blocked over there. So what happens is, major thing is when they undergo PET scan, at times, if suppose a patient doesn't have a tumor at all, due to this, the tracer, which is a very high toxic substance, they get lot of problem. The side effects, okay, or the effects created is really high, because of which they suffer for few months also, we cannot say. And next important thing is small lesions, usually we miss it out. We cannot predict it using our PET. So when it comes to the machine learning, through our imaging techniques and from the data received, it will be, when we're trying to apply some algorithms and all, it will be easy for us to predict even small lesions, and we can avoid patients most probably getting into the PET scans. Yes. So I will just browse into the various steps involved when you're trying to carry out the machine learning. So the previous two experts have explained about the various techniques used, the various algorithms and all. Let us check on the steps, how step by step we go for developing a model and how well we can do it. So most thing I wish to highlight over here is, when it comes to any machine learning process, data plays a key role. So if suppose you're planning to work on machine learning, or you're trying to learn machine learning in a very practical manner, you're trying to develop some small projects using any particular tool, the first thing is the data. If the data is not going to be appropriate, we cannot expect our model to produce the expected result. I cannot take an image of a cat and train a model and expect my model to predict that cat as a dog. Next to impossible. So whatever data you feed in plays a key role. And here again, the historical experience plays a key role. That's what I was telling. Once we discuss with the medical experts like doctors, we get to know this is how a patient suffering from this particular disease might behave, or these are the symptoms what might be present, right? So with all that data only, we can go for literally training our model. So how we collect the data, and second thing, after we have, for example, in my research area, I had to collect the mammographic images, and it was not so easy for any hospitals to share the images. And that alone was not sufficient. It is not just collecting the mammographic images. Literally, I had to interact with doctors. I took almost 2.5 to 3 years to interact with doctors and understand that so-called tumor and this mammographic effects and all in medical terms. Their perceptions are entirely different. So as I can also tell, when you start developing a model dealing with data, to some extent, it's like data analytics. So as a data analyst, we should be aware of how that data is being used, how we collect it. Next important thing is whether all the collected data is literally needed for processing. No, certain things will be unwanted. So how effectively we are going to group the data, how effectively we are going to handle that data, okay, how we are going to choose among so much which best can be used for my processing. That is next important step, which will be dealt in our pre-processing. Next important thing is how I transform my data. Why transformation comes into picture is, we'll be having data from various modalities, right? From different places we'll be collecting the data. So how well we try to integrate, bring it all into one particular data type, and how best we try to give it as an input to the model. It's very important. Next important thing is choosing an appropriate algorithm. So with all this experience, we need to identify a very perfect algorithm in order to handle the data. Next important thing is how well we come out with the patterns, how we match the input data to the output labeling. When it comes to supervised learning, we need to model, train our model perfectly, telling if this is the input data, this has to be the output data. So having trained, our model gains the knowledge. So this is how our model has the it creates a knowledge repository. From the knowledge repository only, it keeps on retrieving when it starts working with the new data. It compares and contrasts. If these are the input data which is being given, then what should be the output? It just goes back to the knowledge repository, compares it, brings out the label, and just displays over there. So all these various steps, it looks very simple when I project it over here, but every step in turn, okay, every step in turn is like a research domain. So still research is going on in all the steps of any particular machine learning process. Fine. So I have to give more emphasis on the pre-processing is what I felt, because when it comes to healthcare domain, pre-processing techniques plays a major role. It's very important. Pre-processing means what? Before we try to literally handle the data, before we try to apply some algorithm to the data, before we try to process the data, I have to do some pre-processing. I need to do some cleaning. I need to remove unwanted data. I need to check whether some data is missing, whether some data has gone wrong. When I'm collecting the image itself, slightly if there was some problem during the recording, okay, when the scan was happening, something went wrong somewhere. Obviously, immediately the data what got stored or recorded will be 100% wrong due to noises in terms of electric impulses, noises in terms of unwanted data which is present on the whole image, noises in terms of something being hidden. For example, we are not able to visualize that x-ray image or something properly, that itself becomes a noise. So I can't extract any data from there. So how will I go for extracting the actual data? What is needed to process, right, to train my model? That data, how am I going to get it? Apart from all these noises, how I can go for handling that? So that whole thing comes into pre-processing. So it's like all about transforming the data to the form however you want. At times it also deals with reduction. For example, I might have around 1 lakh features or attributes or characteristics which is being retrieved, the data from my input image. All 1 lakh data will not be processed immediately. So how will I go for choosing which particular data is needed for processing? So all this determines a pre-processing stage in our machine learning process. Next important thing when it comes to the MRI, CT scan, and all scanned images is the pixel brightness transformation. Various techniques are being used when it comes to pre-processing. In that, these are very, very important. Why pixel brightness transformation? Basically, when it comes to an image, as all of us are aware of, each and every picture element, okay, the data stored, if it's the color image, every pixel element is going to have an RGB component at the back end. So what happens, the combinations of those determines the actual numerical value in that particular picture element. So if there is some problem in that combination, might be due to illumination, right? Illumination was not perfect. I did not get the right level of RGB value. Obviously, the numerical value what I extract from that picture element is not equal to the original value. So when I'm trying to handle my data, or when I'm trying to retrieve my numeric data through each and every pixel element in an image, it's very, very important to see to that the image is typically the same as the original source. It cannot vary. It cannot have too much deviation. Then there is no point in retrieving the data from that image and then processing it. So pixel brightness transformation. Similarly, when it comes to your X-ray images, we call it as a gray level. So again, we need to see to that the contrast, basically. Again, here also I wish to tell something. All of you will be having the photo editor tools in your mobiles. You keep on working on it. You play with the brightness, you play with the hue, you play with the cropping. All these are nothing but image processing techniques. It's been so simplified nowadays. It's readily available at hand. So what happens is the same thing. How will you adjust the brightness? How will you adjust the contrast over there? So if you have seen, it will be displaying the histogram, okay, a sort of lines which is getting displayed over there. So that histogram, which gives a pixel intensity value. So how well that intensity, that pixel strength is spread across in the image, how even it is. It shouldn't be too much collected. One part of the image cannot be too bright, other cannot be too dark. That is not an even image. So how well things are literally scattered, or how well the contrast is stretched across a whole image, determines the quality of the image, because we are going to retrieve the data from this and then only we are going to process it. And if needed, we need to get into geometric transformations, as I was mentioning just now, the rotate operation, the cropping, several transformations can be taking place, and interpolation. So after all this pre-processing technique only, we go for literally extracting the data. So first important thing when you carry out any machine learning courses or something is to understand what literally data collection means, what data transformation means. Next important thing is a pre-processing techniques. Yes. So basically any particular machine learning algorithm, okay, how it works. So this totally I had prepared with all the small projects what we have carried out over here. So basically, for any machine learning algorithm to work or to apply your machine learning approach, first and foremost what you need is a collection of features or attributes, or basically called as a data set. The table on the left hand side corner with the columns labeled as F1, F2, F3 and all, that is nothing but our data set. So we'll be collecting lot many instances. Instances is nothing but the values from different, for example, let me take the same mammographic images only. By suppose if I've got around 200 mammographic images, so in each and every mammographic image, I have to extract certain features. For example, what is the size, okay, the shape, and then the texture of the tumor. So many things are there. So when such type of features I list out over here, from how many images I'm able to collect the data, that determines efficiency of my model. More the number of instances, better my model will learn very quickly, very easily. It will get to know these all might be the combinations of data I might get, and this is how I have to do my prediction. So first I collect all my data and I place it in my data set. So as I was mentioning, once that data is being placed in the data set, it's very important for me to understand which data I'm going to use and which one I'm going to skip. All the pre-processing techniques will be applied. From there, we go for choosing an appropriate algorithm. So as a machine learning model or an analyst or a developer, your role, very important role, will be in identifying the appropriate algorithm. So this is the major challenge, whether it's going to be supervised or unsupervised or reinforcement, what type of methodology will be suiting for this particular model in order to do the appropriate prediction. So we choose the algorithm. Thereafter, we go for building the model. When I'm developing a model, very important thing is with whatever data I have collected, I go for dividing the data into training set and testing set. So few data instances will be used for training my model, literally to make my model understand if these are the data, this should be the result. Okay, exclusively in the case of supervised. And when it comes to testing, obviously my model will be tested. The remaining instances will be given as input to my model, and we need to check if my model is producing the appropriate result. So based on the predicted output or result, I again go for changing, making some corrections to my model. I go for fine tuning it. I try, for example, when it comes to artificial neural network, it's going to be called as epochs, the number of trainings. So I keep on giving input. I set the activation functions and values in every internal nodes, right? And I set the bias, weights, everything. But But finally, what is very important over here is after multiple training, after the multiple epochs, I just try to find out what is the output. How, if suppose I feed it in some 200 data, out of 200, it has predicted around so many, like 198 something. Then this is going to be 198. I predicted perfectly without any error. So this is my precision, right? That is a precision of my algorithm. So based on that precision and what is the expectation of the medical experts, I try to correlate and then I go for fine tuning my model where it has gone wrong. And one more thing we need to remember over here is about our training. So we can never go for overfitting the model. We have seen this scenario in other subjects also. There's something called as overfitting, underfitting. So what happens is overfitting is exact one-to-one. For example, if I have around 1 lakh instances in this data set, I develop a model, it works very perfectly for these 1 lakh instances. On the other hand, apart from this 1 lakh, I try to bring one more extra. My model doesn't give the proper result, which means it is one-on-one mapping. This model is exactly mapped only to this 1 lakh instances. That is overfitting typically. When it comes to underfitting, it's like literally not working properly for this particular 1 lakh data set itself. So what is expected moderate? So moderate level means what? Out of this 1 lakh, I can have certain error conditions. Nothing wrong. There is no hard and fast rule. All the 1 lakh data has to be predicted properly. I can have certain very minimal based on the system. See, when it comes to healthcare, there are critical systems. There are critical conditions. There I cannot take a chance. I cannot take a chance such that the person dies next day. No. But based on the application where we are trying to use, based on the severity of the scenario, I can go for giving some flexibility. So if based on that error condition, it's going to be easy for me to fine tune the model. So that is how I fine tune. I try to see it works fine so that when I give some new data also, my model will be able to do the prediction to this particular percentage. Might be 98% accuracy, 99.99% accuracy. Agreed. Once the experts are happy with it, yes, we can go ahead. So this is how basically stepwise we work. We develop any particular model. Yes, so I think this topic was touched upon, so I need not go in depth with this. So all of us by now we got to understand the different types of learnings are supervised, unsupervised, and reinforcement. Basically, all algorithms, whatever we have in machine learning, it will be falling into any one of these categories. So when it comes to supervised, it's like directly we are feeding into the model telling this is what the label has to be. If suppose this is the image what I give as input, it should be called this way. That is supervised. When it comes to unsupervised, as all of us know, we are going to allow the model to do the prediction. So maximum clustering algorithms will be falling under unsupervised algorithm. So if suppose we pose a question, what type of learning is best preferred when it comes to our healthcare domain models? 99% of the time, we prefer supervised learning. The reason being, we're playing with people's life. We cannot take too much risk. So if you are a machine learning analyst, okay, if you are a interact with the experts, understand the various types of problems and diseases. It's like what are the symptoms, how they have to react to it, what type of treatment, so many X, Y, Z, lot many things are there. You collect all the data and then you go for developing a model so that when a patient installs your particular app, okay, into their system, they just feed in the basic metrics. For example, the very basic measurable metrics from home. If they are trying to feed in their bodily changes, when they feed in, at least your model will be able to predict to some extent the first aid that they can take up. Suppose some critical heart problem, okay, or something is life threatening, it can at least save their life for another 2-3 years by the time they reach a hospital. Worst come worst case. So that is where we have to be very cautious, because we cannot allow the system to predict. We cannot tell you read all the symptoms from the patient, then you go for identifying what is the problem. No, that will become too risky. But on the other hand, if suppose people in the laboratories, they are trying to identify what type of disease it is, okay, something has come out, so what type of disease it is, what type of disease a patient has, and what type of drug has to be administered to the patient. For all these things, to some extent they can go with unsupervised, because they can allow the model with its prior knowledge to literally group the attributes, identify the correlation between the features, right? They can allow it to think upon itself, and then based on the correlation between the attribute value, how well it can group the value, and through that they can try to come out with a solution. Okay, this is the type of virus or this is the type of bacteria which has infected, and for this might be the drug. Okay, so that is how we can make use of unsupervised learning. So the a place where the type of learning is applied varies when it comes to patients and handling them. Okay, literally playing with their life, better to go with supervised. When it comes to the drug development, identifying what type of new microorganisms has come out, what type of disease have come out, for that to some extent we can make use of unsupervised learning. Yes, so I'm not getting much into this. We have just checked it out now. So next very important thing when it comes to machine learning in the healthcare domain is dimensionality reduction. As I was mentioning till now, whenever we have the images, our CT scan, all these images, next important thing what I need to do is I need to extract the features. Features are nothing but the characteristics for which I need to select the features first. I should be aware of these are the characteristics which I need to extract from the image. For example, length of the bone, depth of the bone, okay, and like the size of the tumor completely. Okay, so many features. So what happens is before doing into it, what is more important is dimensionality reduction. In fact, this concept is very important when it comes to hyperspectral images also. They are also, it's like default dimensionality reduction. So what we need to do is whenever we have a higher dimensional data set, there is no guarantee like you're going to get appropriate data. It's like you have voluminous amount of data, but to what extent that is going to be perfect for your deployment of your model is always a question mark. So never get into assumption too much data will help me to develop a best model. No, never like that. Appropriate data, perfect data is going to help you to develop a perfect model. So that is where dimensionality reduction plays a key role. So when we try to reduce the dimensions of the particular data set, whatever we have in hand, literally identify which is very important over there. Okay, then our model gives a better result. So it's very, very important because choosing your features, selecting the appropriate characteristics, the attributes of the features, and extracting those values, everything depends upon the dimensionality. Means how much amount of data you have in hand and how much appropriate data you have in hand. So this is another important thing when it comes to ML in healthcare. Right. So as I was mentioning now, next important thing we all should be aware of when it comes to machine learning in healthcare sector is nothing but the feature selection. So how best we go for selecting the features? Features are nothing but, as I keep on repeating, the attributes or the data values basically. So when I have voluminous amount of data, how well I go for selecting how perfectly I select the features. As it was mentioned in the previous sessions, right? It was ma'am had taken one beautiful example of an apple. The same thing I wish to share, my dear friends. When you take a particular fruit, it has certain characteristics. The color is red, of this particular shape, it is edible, okay, and maximum of this particular radius. Obviously, a machine doesn't know it is an apple, but with all these things, since we have given the label as an apple, obviously it will identify that as an apple. It's typical to how we were trained when we were kids, our childhood experience, the same way. So what features you appropriately select from your medical images, how beautifully you extract it, how perfectly you extract it, and how well you label the combination of the features determines the performance of your model. These are all challenging. That's what I told. Feature selection itself is a research domain. Which algorithm is best suited for selecting an appropriate feature? It's is in its own way a research. So that is how people are still working on it. Which best algorithm can be used for selecting the appropriate features given the scenario? Okay, given a particular scenario, and this should be the result. How well we can go for selecting a feature. So we have several approaches for that. Filter approach, wrapper, embedded approach, lot many approaches we have. And nowadays we even go for hybrid combinations. Hybrid combination of approaches through which we'll be able to predict the appropriate, extract the appropriate features. Right. So The next important thing, or almost the last part of your ML process, will be the classification. So put in simple terms, what we want the experts, what we are expecting from the model. The person has this disease or doesn't have the disease. The person has this problem, doesn't have the problem, right? That is what we need. So finally, it is all about classification. So again, we have several algorithms under classification, but finally, how my model classifies, how it tells whether the person has a problem or not, is totally based on all the steps what I've covered till now, starting from data collection to pre-processing to the dimensional detection, feature extraction, selection, then step by step the appropriate algorithm. All this determines my final classification result. So if my model is, once I've developed a model, it is not only about the algorithm. So if the input is not proper, the model doesn't give a result. Everything initially is perfect, but the algorithm is not perfect. I'm not going to get an accurate result. So classification is something literally what the experts see on the screen. Okay, I'll just get back to this. I will let you know. So if you just see the tumor, okay, the tumor example what I've taken here. So what happens is, if you can see that green and the pink light, the bordering over there. So the pink one is something which was put by the radiologists, the experts manually. They just showed in their system, and the green one is something which was predicted by my model. So how far this matches? Okay, the maximum match, okay, accurate match. Only that type of model will be accepted by the experts. So how this particular thing happens is how efficiently you go for developing your model, how efficiently you bring out your algorithm, how efficiently you identify this is how the problem is and this is how it has to be handled. So in every step, the algorithm or approach chosen plays a key role. Right. So one of the common approaches used for classification nowadays, the best preferred one is neural network, wherein we have gone till your convolutional neural network. So what happens over here is, as we all know, the neural network has several layers. We have the input layer, the final output layer through which we get the classification results. And apart from that, we have lot many intermediary layers. So it is all a connectivity of nodes, and each and every node is going to have activation function inbuilt in it. And along with that, we are going to have something called as weights assigned to each and every input value and the results from every node, and a bias factor, which is like plus or minus, values with respect to the activation function. So all these things put together, how the neural network processes the features determines the final classification. So I've just taken the example of the tumor part only. So based on the features what I've input, my neural network is able to classify the input image. What I give as input here is just an MRM image. Okay, a mammographic image. But what is the result I see on the output screen is whether it is normal, benign, or malignant. So how much process involved in the back end is nothing but my is nothing but my. Yes. So similarly, this approach was used for stage recognition. So lot many features were input, around the 28 to 30 features with a different, different level of understanding. For example, scaling, like the dimensions, energies, multiple things. So all those features are input, several level of processing happened. And finally, the malignant tumors were also classified as stage 1 and stage 2. So several, it's not like we just develop a model, we apply the techniques appropriately, we just feed in the data, train it, and allow it to test. So what is the reason for testing? Post testing, I should be able to tell how much my model is reliable, whether I can use it in real time. Okay, whether the experts can completely rely upon my model. So for that, we have several evaluation and interpretation metrics. It's like almost with a ground truth, we try to compare our model. So we have the gold standard and several metrics can be used. It is not only the ones what I've defined over here, but when it comes to healthcare system, these are the things which they will be concentrating more upon. The experts will be seeking for efficiency. You cannot tell my model is like 99% accurate, 1% I cannot guarantee whether the person will be alive or not, the patient will be alive or not. No, accuracy, very very important. Next important thing is the response time. I cannot develop a model which is going to take around 2 to 3 days to give the results. Gone are the days. We all need instant results as well accurate result, which is a major challenge for developing a model in the healthcare domain. Then to what extent it is applicable across platforms? Okay, it's like as I just started the session in the beginning, I should be able to fetch my data through any particular medium, right? In any particular location. The data will be processed around, say, without affecting my gadget. It can be a wearable, a smartwatch, some wearable, what I'm wearing. Through that wearable, I should be able to get the result. So it can be any medium, any particular mode, but my model has to work perfectly, and to what extent it is reliable. So these are some basic things which were told by experts themselves. They themselves told what they're expecting from a machine learning model, and based on which they will literally decide to take a call upon to believe that model will give them results or not. Yes. So with this, I end my session. Once again, thanks for the opportunity, and it's open for question now. Anybody wishes to ask any doubts, you can get it. You can feel free to.
Thank you, ma'am. Participants, any question from your side? If participants have any doubt, you can please ask or even post the question in chat box.
Fine, ma'am. So if needed, I can share my mail ID. They can post their questions over mail also. I would be happy to handle the queries.
Okay. Thank you, ma'am, for enlightening by introducing the role of ML and its application in healthcare. Ma'am also explained in brief about systematic approach to carry out research in healthcare domain. I hope that researchers get familiarized with the importance of machine learning role in healthcare. Thank you, ma'am. Ma'am, I have few, okay, participants had posted the questions in chat box.
Sure, ma'am. Okay. Sorry, I'm not able to check.
So the first question is, how can we know appropriate algorithm to use in analyzing data?
Yeah. Okay. As friends, as I was mentioning, the selection of the algorithm is completely dependent upon your knowledge. If you are going to develop a model, you should have a best insight about what is the problem in hand. What is the problem statement we have in hand? If suppose my aim is to, let me get back to the same scenario. My aim is to predict the tumor. Obviously, see, I was into computer engineering, right? Literally, hardly I know anything about medical. I cannot take it as an excuse. I cannot tell like I don't know anything in medical terms and I can't go for developing a model. I need to interact. You need to understand the problem statement in depth and literally interact with people. Once you have understood the problem statement and you have an idea about how the results has to be, then it will become easy for you to choose the appropriate algorithm. And obviously, the second step is very basic thing. What all of us do in our research is survey. You need to do a rigorous survey, identify what are the various algorithms used to solve a similar problem and what is its performance, and that would also help you to choose the best algorithm. Yes.
Ma'am, one more question. Amita
Yeah.
ma'am, would you like to ask? Okay, ma'am has posted, does the skull stripping methods remove noise also? Or we have to
Yes,
do
to some
first
extent.
pre-processing and then skull stripping?
Yeah. So of course, the approach, Sal stripping, I've heard about it, but the thing is like when it comes to, always in the medical application, it is slightly risky. The reason is it works completely on the threshold. When it goes your skull stripping, and in fact, certain pre-processing technique, we try to set a threshold. So that threshold, again, mind, that's again based on our prior knowledge. So if that threshold is not, to some extent, if it is not appropriate, thereafter, when I go for pre-processing, again, to what extent my raw data is perfect is always a question mark for me. So I would suggest to first complete the basic pre-processing technique, then we can take a call on skull stripping based on the application again. Huh. Hope I have answered to the question.
Okay, ma'am, one more question.
Yeah.
As you have performed research for detection of malignant tumor at early stage, so have you applied for any funding agency for the same?
Huh. Okay. One thing is like I had gone ahead for patenting my research work for 3D images. So that was a major reason I was not able to, disclose my approach, because it was a novel algorithm what I had used for the region of interest detection, what I displayed over here, plus the staging technique. It's very novel. So one thing they told was first I have to patent it. So I've gone ahead and past 2 years I had worked on it and I've patented my work. And something related to this, not using exactly the same technique as what I have used. Something correlated related to this. Yes, I had tried for applying for funding agency, but only thing what happened was they have asked me to get connected with some hospitals, identify. This is something what I want to share apart from my research. Generally also I want to share. Nowadays it's going like when it comes to funding, literally we need to identify the need of the funding agency. Suppose if a particular agency is ready to give me some funds to develop the models, what happens is where it is going to be applied, the real-time application. So in that way I got some support from this industry. They came forward, and to some extent it worked out, but again it is still in the processing stage only. We are working on it. So we need to get tied up with certain hospitals and certain industries who will be supporting us in the whole process. Yes.
Ma'am, can you please share your mail ID as participants?
Yeah,
Many of the
sure.
participants are working on the same domain. So,
Wonderful. Okay. I'm happy. So I'll share my mail ID. Kindly take care of my spelling. My spelling will be slightly different. You can just copy paste the mail ID. Yeah. So varalakshmi.csc@cambridge.edu.in. I'll be always happy to get connected with more researchers. It will be helping me to gain more knowledge. So please do, get back over mail. We can work in a coordinated manner. Yeah.
okay, thanks a lot, ma'am, for very informative session.
Thank
Now,
you.
participants, we will break for lunch. We will be resuming the conference at sharp 1:30 p.m. You can use the same link for rejoining the conference. The feedback link will be mailed at the end of the day. I request participants to give their feedback to all the and certificates will be provided to the participants once you have submit the feedback form. Thank you. So we will rejoin at 1:30 using same link.